Yeah. Find the HCF and LCM of 672 and 120 using the prime factorization method. Okay, answer. This is prime factorization method. That means we have to prime factorize the each number 672 and 120. Then we can find HCF and LCM. First I will take number 6. We have to write it as product of prime numbers. So prime number, so 2 is a prime number because it has only two factors that can divide this two completely. One first number is 1 and second number is the same number 2. Only this and this can divide this two completely. No other number can divide this two. So this number has only two factors, so that is prime number. Okay. Similar to prime numbers, there are many. Similar to this two, there are many other prime numbers. I will write now. So first prime number is 2, after that 3, after that 5, 7, after that 11, etc, 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 like that. Okay. So prime factorization means we have to write this number as product of prime numbers. These are the prime numbers. That is the prime factorization. So first we will find the prime factors of this 6. So write this 6 here, write like this. Now check first prime number 2 whether this can divide this 6 completely or not. So this 2 can divide this 6 completely. So write this 2 as it is. Now 2 3s are 6. Okay. Next check the same number. First for this write like this. Check the same number whether this divides 3 completely or not. First you have to check this. If this don't divide this, then you have to go for next number. Okay. But if this number is dividing this, you have to take this only. Now see, this 3 can be divided by this 2 completely. So 2 right here. Sorry, 2 is not. Sorry. Okay. This 2 cannot divide 3 completely. So we have to check the next number. Next number is 3. So that 3 right here. Now 3 ones are 3. Okay. Now if you get 1 here, you have to stop the division process. Now except this one, whatever the prime numbers here you have taken for dividing. So this you have to consider. First write this 2, leave space, next write 3, in between write into. So now this is prime factorization. We have written 6 as the product or multiplication, both are same. So multiplication of two prime numbers. 2 is prime number, 3 is number, 3 is a prime number. So these are the prime factors and this is called prime factorization. That's what prime factorization. Okay. Prime factorization means writing the number as product of prime numbers. That is prime factorization. So we are done with this. Similar to 6, we have to write the prime factors for 72 also. Now I will take 72. Okay, 72 I will take. Here I will write 72, write like this. First check whether this 2 can divide this 72 or not. Yes, 2 can divide this 72 completely. So I will take this 2 here. Now 236. 236 the 72 you will get. Again for this number you put like this. Again check whether this 2 can divide this 36 completely or not. Yes, this 2 can divide this 36 completely. So I will take this 2 again here. Now 2 18s the 36 we will get. Again for this number you put like this. Again check So this 2 can divide this 18 completely. So I will take this 2 again. Now 2 nines are 18 you will get. Okay. Now for this 9 you put like this. So check whether this 2 can divide this 9 completely or not. No. If you divide 9 by 2, you get a decimal number. It is 4.5 you will get. So if you get decimal number, so 2 cannot divide 9 completely. So check the next prime number. Next prime number is 3. So this 3 can divide this 9 completely. So I will take this 3 here. Now 3 3s are 9. For this 3 again you put like this. Again check with the same 3 whether this 3 can divide this 3 completely or not. Yes. See this 3 can divide this 3 completely. So I will take this 3 here. Now 3 ones are 3. So when you get 1 here, you stop the division process. So remaining whatever the prime numbers you have taken for division, consider these, write this, leave some space, write this 2, next leave some space, write this 2, next leave some space, write this 3, leave some space, write this 3. Now between the numbers you put into like this. Okay. Now see this is prime factorization. So we have written 72 as a product of prime numbers. So this is the prime factorization of this 72. So similar to this we will take this 120 again. 120 is equal to now take this 120 here, put like this. Now see this first prime number 2 can divide this 120. So I will write this 2 here. Now 260 is a 120. Again for this 60 put like this. Next see this 2 can divide this 60 completely. So I will take this 2 here. I will take this 2 here again. Now 230 is a 60. 230 is a 60. Okay, next for this 30 you take like this. See again this 2 can divide this 30 completely. So I will take this 2 again here. 2 15s at 30. Okay. For 15 again you put like this. See this 2 can divide this 15 completely or not? No, right? 2 cannot divide 15 completely. If you divide we get decimal number. So it's like we get some around 7.5 you will get. So that means this 2 cannot divide this 15 completely. So I will take next prime number. See this 3 can divide this 15 completely. So I will take this 3 and write here. Now 3 5s are 15. For this 5 put like this. So this 3 cannot divide this 5 completely. So next prime number is 5. So this 5 can divide this 5 completely. So I will write this 5 here. Now 5 ones are 5. Okay. Now except this one you consider all other prime numbers that you have used for division purpose. So write this 2, leave some space, write this 2, leave some space, write this 2, leave some space, write this 3, leave some space, write this 5. Now between the numbers you put into. Okay. Now see we have written 120 as the product of prime numbers. So this is prime factorization, this one. We have prime factorized the 120 like this. Okay. So now based on this prime factorization, so we can find HCF and LCM now. So that's what the question. We need to find HCM and LCM. First we will see LCM. See, for LCM there is a definition. Okay. Using the definition we can find the LCM. So I will write the definition for LCM. So LCM is equal to product of highest power of each prime factor involved in the numbers. This is the definition. So I will write LCM is equal to here. Now see, first numbers, that means you have to consider all three numbers 672 and 120. Okay, each prime factor involved in the numbers. Each means all the prime factors you have to consider. So all prime factor means 2, here also 2, here also 2. But when I say consider all prime factor, you take 2 only once. So which are the prime factors? 2 is there, put into, next to 3 is there, next to 2 is already taken, 3 is already taken. Next come here, 2 already taken, this 2 also taken, 3 already taken, so 5. So that's each prime factor involved in the numbers means all the prime factors that are present in the factors of 670 to 120. So all prime factors you have to consider. That is the meaning of from here to here. Next, what they consider? Product means multiplication. I have put into already. Next to highest power of the each prime factor. We have to consider highest power. So before that I will write these prime numbers as powers. You will understand better. See, there is only 2 is there. So here nothing is there means 1 is there. So 2 to the power of 1 into, next 3, nothing is there means 1 is there. So 3 to the power of 1. Next here 2, write first 2. How many 2's are there? 1, 2, 3. So because of 3 2's are there. So 2 to the power of 3, that 3 you write here. There are, see, 2 is taken 3 times, right? There are 3 2's. 1, 2, 3. So that's why I'll write 2 to the power of 3. Put into, next take this 3. So how many 3's are there? 1, 2. 2 are there. That 2 I will write here. Okay. Next, similarly here, first take this number 2. Now how many 2's are there here? 1, 2, 3. 3 are there. So I will write 3 here. So 2 to the power of 3. Put into, next to 3. 3 you write. Here nothing, there is only 1 3, right? There is only 1 3. So 1 you write here. Put into 5 I will take. How many 5's are there? There is only 1 5. So 1 I will write here. So First you have to write powers. These are the powers. This 1 1 3 2 3 1 1. These are the powers. That's what they're telling. Powers. Now what they're telling? Highest power of each prime factor. That means if you take 2, highest power you have to take. Okay. The first wherever 2 is, here 2 is there, no? First I will consider 2. Here 2 is there, here 2 is there, here 2 is there. I will circle the powers. So this is the power, this is power, this is power. Highest power. You take highest power. Which is highest power? Here 1 is there, here 3 is there, here 3 is there. 3, 3 both are same. Leave it. Now 3 is greater than 1, correct? 3 is bigger than 1. That means highest power means the biggest power you have to take. Since 3 is bigger than 1, so I will take this power 3 and I will write here. Okay. Next to 3. So consider 3, here 3, here also 3 is there, here also 3. Now consider the powers of 3. This is power, and this is power. Consider only powers, this 1, this 2 and 1. Which is highest power, which is biggest power? This one same. Now consider this 2. See, this 2 is bigger than 1 and this one also. 2 is the bigger, correct? So this is the highest power, 2. 2 is bigger than 1, so highest power is 2. That 2 you write here. So like that. Next 5 is there. Here no 5, no problem. Here also no 5. There is only 1 5 and power also 1 is there. So write that. There is no other 5 to compare which power is bigger. There is only 1 5. Since only 1 5 with power 1 is there, so same thing you write here. Now next step. So we have to simplify. 2 cube means 8. 2 cube means 2 into 2 into 2. 2 to the 4, 4 to the 8, like that. I'll write here if you confuse. 2 cube means 2 into 2 into 2. 2 cube means 2 3 times. 1, 2, 3. 3 times I have taken 2. So 2 to the 4, 4 to the 8. That 8 I have written into. 3 square means 3 into 3. 3 3 is a 9. So 9 I will write here. Next into 5 to the power of 1. Since here 1 is there, so 5 to the power of 1 means we get 5 only. Sorry. Now we have to simplify. See, we have to simplify this. Just multiply. 8 into 9. 8 into 9 is 72. I'll write here. 8 into 9 is 72. Okay. That 72 into 5. How much you will get? This 8 9 is 72 and into 5 I have written. Now multiply these two. 360 I got. Okay, yeah. 72 into 5 is 360. Okay. See, this is the answer. LCM is equal to 360 is the answer. Okay. So this is done. Next we have one more thing we need to find. That is HCF. So we will find that. How can you find? Similar to LCM, there is a definition for HCF. Using that we can find. I will show now. So I will just erase this question part. Okay. Yeah. So any previous content if you want to see, you can move the video backward. Okay. I will write the definition for HCF here. We got LCM is equal to 360, right? I will write this answer here somewhere. So LCM is equal to 360 we got. So I will just rub this. Here I erased, I just rubbed something. I will rewrite. I will write it again. 72, right? So 2 cube 3 square. This I had written something here, that is 2 cube into 3 to the power 1 into 5 to the power 1. This I already explained. I just I had rubbed this, so once again I written here. Okay. Yeah, we are discussing about HCF. So I will write definition for HCF. So this is the definition. See, product of the smallest power. Smallest power of each common prime factor. Each common prime factor in the numbers. So in exam you write full like NUMBERS numbers. Here I have just written short form to make you understand. Okay. Now using this definition, so we can find HCF. What it is saying? First numbers. Numbers means you have to consider three numbers, 6, 72 and 122. So when I say consider three numbers means factors. These factors for each number you have to consider. That means this you have to consider, this also you have to consider first. Next, what they are telling? Common prime factor. So these are the prime factors. 2, 3 and 5 are the prime factors. Common means in each of these three, 1, 2, 3, common prime number you find out. Okay. So which is common except the power. Don't consider the powers now. Don't consider the powers. These are the powers. This and all. Consider these number bases. Okay. These prime numbers you consider. So common numbers you consider. When I say common prime factor, please don't consider the powers. This. You consider these numbers. 2, 3, these numbers. So these numbers you consider. These are the prime factors. That's what common prime factor they are telling. Not these powers. First common prime factor you consider. So in these three, which is common? See, here 2 is there, here also 2, here also 2. 2 is common, 2 is present here also. So that is common prime factor. So that you write here. Because that's what telling, common prime factor. Next put into. Next to check, is there any other prime factor which is common? I will take 3. So 3 is present here, even here also 3 is present. Even here also 3 is present. Okay. So 3 is present here also. So consider this. So 3 is common prime factor. So consider 3. Next, if I take 5, 5 is present here only, here. But here no, it is not present. Here also not present. Since 5 is present in only one number, I mean for 120, it is not, it should, if 5 is present here also, then that is common prime factor. But 5 is present only here. So that is not common prime factor. So you should not write here. According to definition, we have to consider common prime factor only. Okay. Next, product means multiplication. I have taken, that is into. Next to Powers. Now consider the powers. Powers of what? Powers of these common prime factors 2 and 3. So powers you consider 2. The power of 2 is here 1. Here 3. Here also 3. Okay. So for 2 you consider powers. Here 1. Here for 2 power is 3. Here for 2 power is 3. What they are telling? Smallest power. Now consider smallest power. Which is smallest power? Here also 3, here also 3. Both are same. So it's no problem. But here 1 is there. So this 3 is greater than 1. Okay. But we need smallest. We don't want biggest. We don't want big number. We want small number. So 1 is smaller than this 3 and 1 is smaller than this 3. So 1 is the smallest power. Smallest power. So take this 1. So right here. Similarly 3. So consider powers of 3. For this 3 power is 1. For this 3 power is 2. For this 3 power is 1. Okay. So powers you consider. Next we have to identify smallest power. Okay. So here 1, the power is 1, here power is 2, here is power is 1. So which is smallest power? 1, right? See, 1 is smaller than 2. This one same. Both are same, no problem. You take any one and compare with other power 2. So 1 is smaller than 2. So 1 is the smallest power. So that's what definition is saying. So smallest power is 1. So you consider 1 here. Okay. Now simplification. 2 to the power 1 means 2 only into 3 to the power 1 means 3 only. Now 2 3 is a 6. So HCF is 6. Got it? See, the question was to find the LCM HCF of this 672 and 120. Correct? So these are the answers. LCM is equal to 360. HCF is equal to 6. Yeah, that's all. Yeah, thank you. Anything if you want to say related to my teaching and the concept, please mention in the comment. Thank you and subscribe.